Hi, everybody. Mr. Wyatt here. And today we are going to be looking at topic 3, lesson 5, evaluating algebraic expressions. So we've already discussed what the word evaluate means, and I have it written up here at the top of the screen, evaluate. And you can see the root word here is value, V-A-L-U. You could even throw the E on the end here if you wish. And then you'd see that full word value. To find the value of something, what is its value? What is it worth? All right, so anyway, let's read this problem together. A bike shop charges by the hour to rent a bike. We have Bob's Bike Rentals here. Related items are rented for a flat fee. We're going to talk about what flat fees are in just a little bit. Write an expression that represents how much it will cost to rent a bike and a helmet for H hours. And then how much will it cost to rent a bike and a helmet for 3 hours? And you can see over here, I have to move myself out of the way here just a little bit so you can see the full sign. There we go. You can see the different rates for different things. It says a bike is $12.50 per hour. But then all these other items, a helmet is $5.25, a lock, $1.75, a basket, $2.25. These 3 items don't say they're charging per hour. They just have a flat fee. That's what flat fees are. That means you're not paying for that helmet $5.25 for 1 hour, double that for 2 hours, triple for 3. No, you just pay $5.25. You can wear the helmet the entire time you're out on the bike. Okay? It's the bike where you're paying $12.50 per hour. So what will be the total cost if you rent the bike for different numbers of hours? Well, it will change. And so that's why we're using H here. H stands for hours, and it represents an amount that can change or vary. That's why we call letters like this that appear in math variables. The root word here, vary. Something that varies is something that changes. We can change the value that we substitute in for H hours. We can rent the bike for 1 hour, for 2 hours, for 3 hours, and so on. And depending on the number of hours that we're renting the bike, it's going to change how much we have to pay. Okay, so for example, I have hours. I'm using H for my variable for the value that can change. And then I can find the total cost by taking the number of hours H and multiplying by $12.50. So what will the total cost be for 1 hour? Well, for 1 hour, you would take 12.50. You got to get this to right here. Times 1, which is $12.50. If you rent for 2 hours, then you would take $12.50, 12.50, times 2. And remember, I can show I'm multiplying by putting the number in parentheses. Up here where you see 1250H, there is no times sign in between this. If there is no operation symbol between this number and this variable, that means you have to multiply them together. That's how we show multiplying when we're working with variables. So anyway, $12.50 times 2 would be $25. If we go 3 hours, then we'd take 12.50 times 3. And you know, there's another pattern that's developing here as well. 12.50 times 3 is $37.50. What you're going to notice is every time we add an hour, we're adding $12.50. So we're adding 12.50 each time. And every time you're adding 12.50, you could say you're multiplying by 1, then by 2, then by 3, because multiplying is just repeated addition. If you have 4 hours, you'd take 12.50 times 4. If it's 5 hours, you'd take 12.50 times 5 to find the total cost for renting the bike. So here you get $50. Here you'd have $62.50. Okay, so how much you pay to rent the bike changes depending upon the number of hours. the value that you substitute in for h in our expression here, 1250h. But remember, there also is a flat fee to rent a helmet. Okay, how much would it cost to rent a bike and a helmet for 3 hours? So to rent the bike, you take 1250. I got to get the pen to work here. Times the number of hours. But then we're going to add on that flat fee for the helmet because we want to rent a bike and a helmet. The helmet is $5.25. Okay, so we take 1250 times h, the number of hours, plus 525. This expression right here is what we can use to find out how much it would cost to rent the bicycle any number of hours and also a helmet. And boy, I tell you, this elephant, I'm surprised Bob's Bike Rentals had that large a helmet. Anyway, all right, how much would it cost to rent a bike and a helmet for 3 hours? Well, we're going to substitute 3 in place of the h, and we have 1250 times 3 hours, and then we'll add $5.25. Again, I'm not taking that times 3 because we're not paying by the hour for the helmet, just for the bicycle. All right, now we already did 1250 times 3 on the previous page. You can see that was $37.50. Then we add to that $5.25, which is how much we're paying for to use the helmet. Okay, and then when we add these together, we get $42.75. Okay, and that would be the total cost to rent that bike for 3 hours and also the helmet. Okay, so I hope that makes sense how that works. Let's look at another example. We have this guy named Eric. Eric collects miniature cars. He has one large case that has 20 cars. All right, and I better move myself here again. Oh, right up there. So here we have a case right here that has 20 cars in it, okay? We have 20 cars here. That's kind of hard to see. Maybe I'll go with black so it's a little bit darker on there. There's 20 cars. He has one large case that has 20 cars. He also has 3 same size smaller cases that are filled with cars. Here are those 3 smaller cases that are filled with cars. The problem is we do not know how many cars there are in each of these cases. We know we have, it's 2 by something, but then it kind of gets blocked here behind this box. All right, so he has 3 same size smaller cases filled with cars. Let n equal the number of cars in each of the smaller cases. And so we have an expression that we can write to represent the total number of cars that Eric has, 20 plus 3n. He has 20 cars in the big case. He has a certain number n of cars in the smaller cases, times 3 because there are 3 of those cases. Okay, so what if the smaller case holds 10 cars? What if it holds 12 cars? What if it holds 14 cars? When I evaluate this expression, I'll get a different result for each of those. If each of them holds 10 cars, then I would have 20 plus 3 times 10. But if they each hold 12 cars, I would have 20 plus 3 times 12. And if those smaller cases each had 14 cars, then his total number of cars could be expressed as 20 plus 3 times 14. It'll be a different total number of cars depending upon the size of his smaller cases and how many cars he has in them. If each of those has 10 cars, then 3 times 10 is 30. 20 plus 30 is 50 cars. 50 miniature cars. But if each of those cases holds 12, 3 times 12 is 36. 20 plus 36 is 56 cars. And if they each hold 14 cars, then we'd have 20 plus 3 times 14, which is 42, and then 20 plus 42 is 62 cars. So we don't know how many cars he has, but we do know how many cars he has if there are 10 in each of the smaller cases, 12 in each of the smaller cases, or 14 in each of the smaller cases. But we get a different value depending on what we are substituting in place of n. Are we substituting in 10, 12, 14, something else? The value changes depending what you substitute in. All right, so evaluate this expression, 5a plus 2b divided by c plus d squared for a equals 9, b equals 6, c equals 3, and d equals 5. So what I'm going to do is take these different numbers and substitute them in for a, b, c, and d in this original expression. Okay, so let's go ahead and do that here. Oops, right here's our expression. 5a, that means 5 times a. So that's 5 times 9. A is 9. Again, I like to show I'm multiplying by using parentheses. Plus 2 times b. 2b means 2 times b. b is 6, so that's 2 times 6 divided by, we're going to have to be careful with order of operations, c, which is 3, plus d squared. d is 5, so I have 5 squared. Order of operations says do your exponents. I know it says grouping symbols or parentheses, but these really don't have anything inside of them to solve. They just mean we're multiplying. Okay, so we'll do 5 squared, which is 25. So we're adding 25 at the end. I can do my multiplying here, and my dividing here after this is done. 5 times 9 is 45, plus 2 times 6 is 12, divided by 3, and then plus 25 now, because 5 squared is 25. All right, so next I do my dividing. I have to divide before I add. So 12 divided by 3, that's 4. So we have 45 plus 4 plus 25. And then just go left to right. 45 plus 4 is 49. 49 plus 25 is 74. So when I evaluate this expression, I get an answer of 74. Okay, if your teacher wants to pause at this point and walk through this step by step, that would be a good thing to do in case I went too quickly there. All right, but I'm moving on to the next problem just because of time. All right, so evaluate each of these expressions for n equals 7, x equals 4, y equals 8, and z equals 1. So all we need to do is substitute these numbers in anytime we see any of these variables, and then just solve the numerical expression that results. 5z, that means 5 times 1, z is 1. I'll write that down, 5 times 1, plus 3n, that means 3 times, let's see what n is. N is 7, so we'll substitute 7 in there. Minus z cubed, z is 1. So we have 1 cubed, which means 1 times 1 times 1. All right, so 5 times 1 is 5, plus 3 times 7, that's 21, minus 1 cubed, 1 times 1 times 1 is 1. And now I can just go left to right. 5 plus 21 is 26. 26 minus 1 is 25. When you're evaluating expressions, you should show all of your work like this, and you're going to see it kind of works its way down as you simplify towards your final answer and looks like an upside down triangle. Over here, I have y, which is 8 squared, divided by 2 times x, x is 4, plus 3 times n is 7, 3 times 7, minus z, which is 1. 8 squared is 64, divided by 2 times 4. I have to do this next because we needed to know what 2x was equal to. That's 8. Plus 3 times 7 is 21, minus 1. And so now all I have to do is 64 divided by 8, which is 8, plus 21, minus 1. So that's 29 minus 1. We get a final answer of 28. Sorry I had to go so fast.